Welcome to Unit 2 of the SAP HANA Introduction. I'm Michael Mirborg, I'm your trainer. Unit 2 is going to deal with the HANA Studio itself, which is the interface we use as a modeler or administrator. It's also going to look under the hood of HANA and see how the architecture is made up. So after completing the first chapter of this lesson, you should be able to understand the in-memory computing in SAP HANA, how to interact with it, basically the structure of the HANA Studio, how to view its perspectives, and how to make use of the functionality that comes with it. You should understand how to configure these perspectives, and you will also see how to create a package and a delivery unit. When you start the SAP HANA Studio, which is our main interface to deal with the HANA database, you will be presented with this overview screen. Here you see, for example, the administration console, the modeler, lifecycle management, and documentation that you could open. So these are all different perspectives. These are part of the Eclipse platform on which the HANA Studio is built on. If you have used IDEs as a developer, for example, for Java-based applications, you might have come across this Eclipse platform before. So these perspectives that we've mentioned here, they are predefined UI layouts or views for several application users. For example, the modeler perspective is primarily used by data architects to create reporting models. On the other hand, the administration console is primarily used by administrators to administrate and monitor the engine. Documentation view, probably used by everyone who wants to see the current available documentation. But to go into it, let's first take a look at the administration console. So this is the administration console that you can see on this slide. So as we said, this is used to administer and monitor SAP HANA instances. When you start it for the first time, there isn't actually a connection to a HANA system maintained yet. The reason being is that you could connect your HANA Studio to numerous or several systems in the same studio. If you want to start, you could select a cheat sheet. This is done by a window, show view, and other. The help cheat sheet, it creates an additional view that you could see on the right-hand side of the slide. Using this view, you could choose to add the system and then navigate to it. But to do so, you could also right-click in the Navigate view and add a system. You would, however, need to know the address of the system. You would need to know its instance number and the user and password combination that you would use for your connection. If it's been provided by perhaps other developers, you could also import a system landscape which has been exported. This export would have been done from another studio. If you do this via the method of importing and exported landscape, you would need to insert the password again because they are not exported. So this left-hand view that we mentioned is the navigator. You could see the HANA instance, and under the HANA instance, if you expand it, you will see the catalog. The catalog itself, it contains different database schemas. You may have come across the term schemas when using other databases. The principle is roughly the same with HANA. You will come to see that there are other ways of interacting with HANA, not just with schemas and the catalog. But under the schema, if we start here, you will see the content that it gives us. We can have views, procedures, tables, or column views. The tables is probably what we're going to start by looking at. Now, these are physical tables. So the physical tables contain actual data. And these physical tables are the only storage area for data within SAP HANA. All the information models that will be created in the modeler, they will result in database view. Therefore, HANA does not persist redundant data for each model. It does not create materialized aggregates. Remember, in traditional data warehouses, you may have a lot of redundant data in terms of aggregate tables. When you create models in HANA, these are stored as column views and are always located in the schema _sys_BIC. The metadata of these schemas are available in _sys_BI. Let's leave the modeler for now. Let's look at the system monitor instead. There is an integrated system monitor which gives you an administration view about the system landscape. Here you can see things such as alerts, performances, volumes and configurations, and you can use this to configure your own HANA system. It's also possible to use the system monitor to configure more than one HANA instance. In this slide that you see on the screen now, one has been selected. You could, in the same client, go into another instance as well. Set a different configuration or see how the physical memory or virtual memory, for example, is behaving with that instance. So this administration console is a quite important perspective. Other things you could do with it is that you could, for example, start or stop an instance. You could perform backup and recovery of an instance, do monitoring like we saw. You could configure the engine instance. It's also very useful for problem analysis should you encounter any troubleshooting that you need to do. So this is a perspective that's pre-delivered by SAP. You could find it by selecting the administration icon in the top right corner, which you see highlighted in this slide. So here we see that these perspectives, they are basically built based on views. The views themselves, they are part of a perspective. So for example, if we want to change perspective, we might want to go into the modeler. What we would do is that we would click on the menu icon, Window, Open Perspective, and choose Modeler. We could also use the Fast Perspective switch, which is on the top right-hand side of the screen. There are other perspectives as well. As you can see in the middle here of the Open Perspective window, we could go into Debug, Lifecycle Management, or we have a perspective for team synchronizing as well. Let's take a look at the modeler perspective. This is probably the perspective that you will spend most of your time if you're going to be a developer in HANA. So in the center of the screen, we are first presented with a quick launch tab. This could be viewed as a home page, similar. So this allows us to very quickly, without going into many menu options, jump into various sections of the tool. We could create new views, which is information models. We could create analytical privileges. We could import or export source schemas, or do other configuration. From here, from within the quick launch, we can also access documentation. So continue a little bit about the model perspective. These models, they are organized in packages. As you can see this icon, it actually looks like a package itself. So this is purely for organization perspective. So within a package, you can kind of see it like a folder. You will have these attribute views, analytic views, calculation views, analytic privileges and procedures. These probably don't mean so much to you yet, but we're going to go into this in further detail later in this course and see what we can do with these. So remember, we are now looking at views or content that we have created ourselves. So anything here will not be physically stored in HANA. It's only metadata. Having mentioned things such as calculation views and attribute views and other views that you build in HANA, we shouldn't confuse this with what is in a perspective. Perspectives are built up of views that are used for the developer to get an overview of what's on the screen. It's a very different concept. So you could say that views in a perspective are basic screen elements. Collection of displayed views combined with a placement within the screen, that builds a perspective. Now each view, it can be moved around via drag and drop to put it into a place where you think it's suitable for you, the type of development that you're looking at right now. For example, if you're doing a lot of activation, you might want the job log to be quite a large part of your screen. That way you would make that view a little bit bigger. Or for example, you could also move it to a different part of the screen. Now let's now say that you've moved around your view so much that you are a little bit lost. Well, don't worry. If you do get stuck, there is a reset button. Reset perspective will restore the screen to the original configuration of its perspective. You could almost call this button a panic button, if you will. It can be useful if you're a bit lost and you can't really see the views that you expect to see. So in summary, we should now have been given a bit of an introduction to how to use in-memory computing in SAP HANA using the structure of the SAP HANA Studio. We should understand that we have perspectives that are made up of views, screen elements. We see here that we are now going to also look at creating a package. We saw them earlier, and we understand that they are folders containing the content we've created. We are now going to go into a demo and see how to create a package and also a delivery unit. So follow me to the demo. We are now going to start HANA Studio for the first time. HANA Studio is a Windows-based application. Will have to be installed as a fat client onto a machine. So we've got it installed here now. It creates an executable in the folder SAP in-memory computing. We start it up for the first time. We are now presented with a modular perspective. Remember that we have these different types of perspectives that we can use depending on the purpose that we are loading the HANA Studio. So, in the middle here, we have the quick launch that we saw earlier. I could potentially close quick launch, say I'm doing something else, but I want to see it again. Where do I find it? Well, let's go into Help, and there we see the quick launch. You can open it up again. So, what we want to do now is to change the perspective to start with. What I am going to do is I'm going to go into Window. I'm going to go to Open Perspective. Don't want the lifecycle management. I don't want the modeler. I'm going to choose Other. I'm going to start here with the Administration Console, which is the default perspective. Okay. So remember, we now have the Navigator view on the left-hand side. What I want to do with this Navigator view, I already have some systems installed here, but I want to add another one. It could also be that I don't have any. So for now, I will right-click here. I will choose to add a system. You might remember that we could have used the cheat sheets as well, but I'm going to do it without cheating, so to speak. Okay, so first thing I need to do, I need to know the host name of the HANA database that I'm connecting to. So I know it, WTF LBMT 7211. Okay. I'm going to choose instance 1 because I know that one is up and running. Okay. I'm going to give it a description as well. I'm going to say this is the student 16 demo because we are going to create a connection now authenticated by database user. So we're going to log into the system using student 16, which is a named user. Okay. Now, the first time we log in, the default setting of the HANA database is that we should change the password. So I'm going to change that. Successfully changed. Okay. So I now have a new entry in the navigator view. I have the student 16. If I hover over it, I see that it's connected to WDF LBMP 7211, instance 1, which is the HANA database. All services are started here. I'm logged in with the database user, student 16. Okay, so what we can now do is expand this system, look at the catalog. So the catalog contains the physical tables that are in the database. This is not content that we created. This is physical data. Okay. We have a number of schemas here. For example, we have our own schema, student 16. I want us to take a look at this schema, EPM model, which has some data in it already. Let's expand that one. Okay. See the different type of fairly typical database objects. Remember, this is still in the physical part of HANA. Okay, I am going to take a look at the tables. So I'm going to expand that. From the EPM model, we have a number of tables. Sometimes there could be so many, depending on the source system that you may have replicated into HANA, that it could be useful to filter it. I'm going to try that. I'm going to right-click on it and say I want to filter. I only want to see any tables that start with SNWD. Okay. See how it's filtered. It highlights that we've got a filter on at the moment. Take a look at one of these tables. SNWD underscore PO, I know it's a purchase order table, so we'll look at that one. I'll double click on it. This will now bring up for me a table definition screen. We can see what the kind of columns that we have. We see the types of data types that these contain. For example, we've got a decimal here of 21,7, position, got a character of 3, string length. You can now see here, if we look on the right-hand side, we see that it says type column store. So what that basically means is that this is a column stored table. Take a look at the contents as well. I'll close the definition, right-click on it, open the data preview. Now I see part of the content of this data, of the table. Don't have to just preview. Remember, this is a fully fledged database. What I can do also, I can look at it using SQL. I'll right-click on the connection itself and open the SQL editor. Why don't I just do a very simple SQL statement? I'll do select star, as in select everything from. Here I can actually drag in table. I have to type it. Okay. Execute it, F8, or click the green button here. So now I see part of what's in this table. Okay. What we can now do, we can go into a different schema here. Let's look, for example, at this schema, SAP underscore IC. I'll expand that. I'll look into the tables that we find here. Now, let's look at this table here, IC underscore properties. I'll double click on it to get the table definition. See here, we see a different type. It's calling it row store. This means that the data in this table is stored in a row fashion, in a traditional fashion. If I go and expand EPM model again, we look at the tables. Do you see that these tables have a slightly different icon? Compare them to what we see in SAP and YC. The different icon indicates that it's a different type of storage. We have row storage and in SAP_IC, and we have column storage in EPM model. So for us to create some content, we've only just looked at physical data so far. We would have to then create that within a package. Now to do that, why don't we go into the modular perspective? So previously we've used window open perspective. I'm now going to instead use this quick launch button. So here we've brought up a modular perspective. I want to create a package, but before I do that, in order to follow the right structure, I'm also going to create a delivery unit. That can help me to keep track of what I have created, and it can be grouped together for transportation. I'm going to create a student 16 delivery unit also. I'm going to say the student 16 is responsible for it. This is version 0.1 times. That's all I need to state for now. Okay. Close that. So now I have a delivery unit available. So let's go ahead and create an actual package. Here we have package selected. I'm going to go to create. I'm going to call the package student 16 as well. Give it the same description. Delivery unit will be the student 16. Person responsible should also be student 16. Okay, so what we have now done is that we have created some content. There isn't actually any content yet, but we've got the basis for it. There's a package where we could start adding things. And how to do that, I could, for example, right-click here. I could bring in a new attribute view, analytic view, calculation view. Now, these probably don't mean too much to you just yet, but we're going to go into how to create these types of views or content in units that are coming soon. So this ends the current introduction demo of the SAP HANA Studio. So we are now going to look at the second chapter of this unit, which deals with architecture. That's also the first lesson of this chapter. So after completing this lesson, you should be able to understand the architecture of SAP HANA 1.0, what the persistent layer is, and how it interacts with HANA. You can understand basics of the concepts of backup and recovery as well. So in HANA system architecture, you could have single or multi-host or node configurations. Within each node, you will have different servers, such as the index server, which holds data and execute operations, preprocessor, which preprocesses the data, name server, which maintains landscape information, statistics server, which keeps the statistics in terms of performance data. There's also these services such as the host agent, solution manager diagnostics agent. It's also servers to keep track of updates that are required for HANA Studio and also HANA database itself. So we have two options there, single host configuration or multi-node cluster configuration. Let's look a little bit what's in the node further. At the top, we have the connection session management, which creates and manages sessions and connections for the database clients. So what's a client then? Well, it could, for example, be business service reporting tools, could be other applications. The transaction manager is a component that coordinates transactions, just the way it sounds, also contains controls for the transaction isolations, keeps track of running and closed transactions. Client requests. These are analyzed and executed by the set of components which could be summarized as request processing and execution control. So once a session is established, they don't just stay there normally. They typically send SQL statements to communicate with the database. So this would be with the request processing and execution control. For analytical applications, they typically use the multidimensional query language MDX, which is also supported. For SQL requests, these are received by the SQL processor. Also, data manipulation statements are executed by the SQL processor itself. Other types of requests, they are delegated to other components. For example, data definition statements that defines relational tables, columns, views, indexes, procedures. This would be dispatched to the metadata manager. We'll look at the network connectivity. The SAP HANA database, it also offers connectivity in the sense that you could be running application-specific calculations inside the database system. It's got its own programming language. SQL script is customized for HANA. It's a SQL script language which is built into the database. With this, you could write your own stored procedures like you could in traditional databases. These procedure calls, they would then be forwarded to the stored procedure processes. In terms of network connectivity for the MDX requests, these would be then processed by the MDX engine, forwarded by the to the calculation engine. So these features that we have, these programming languages like SQL script, query language like MDX, or planning operations, they are implemented using the common infrastructure called calculation engine. Furthermore, we also have even further languages such as R for statistics or L for embedded applications. What about high availability on HANA? This is something you would want in order to achieve business continuity. What's available today is high availability per data center. This is done by scaling out with standby. As mentioned, it's available today through some of our hardware partners, Fujitsu, HP, IBM. It's probably going to be more in the future too. Another way of achieving it is disaster tolerance between data centers. It's planned to have metro clusters. This is planned for late 2012. It's not yet implemented, but it's going to be available for us. So HANA, using high availability per data center, scale out with standby. It's already got high availability today. So high availability scale out, how does that work? Well, we have a high availability configuration with a number of active servers in one cluster. It would be a number of standby servers. These would share a file system for all the servers. As for the individual services itself, name and index servers, they exist on all nodes. However, statistics server exists only on one active server. The name server is active on standby. And during failover, what happens? If a server fails, the next server will read indexes from shared storage, connecting to the logical connection of the server. So high availability, that enables the failover of a node within one distributed SAP HANA appliance. And this type of failover, it uses a cold standby node and gets triggered automatically. Up to 3 master name servers can be defined, and during the startup, one server will then be elected as the active master. This active master assigns a volume to each starting index server or no volume in case of standby servers. So in case of a master name server failure, it could also happen, another of the remaining name servers will then become the active master. So when the master name service detects an index server failure, it will then execute a failover, and during this failover, the master name server assigns the volume of the failed index server to the standby server. Now, for standby node failure, we have different implementations per hardware partners. The general parallel file system, GPFS, for example, that's a shared disk clustered file system developed by IBM. You can see on the right-hand side here. We have other implementations by other hardware partners too. As we mentioned, we can also have clusters across data centers, which will be available in the near future. Here, the mirroring is then offered on the storage system level. It will be offered together with the appliance as a special offering by our partners. So the hardware partner itself will define how this concept is realized. The performance impact is to be expected on data changing operations as soon as the synchronous mirroring is activated. So this impact, that will depend on external factors like distance or connection between data centers, etc. The synchronous writing of the log with a concluding commit is probably a crucial part here. In case of an emergency, the primary data center is not available anymore, and a process for the takeover must be initiated. So far, a lot of customers wish to have a manual process here, but an automated process will also be implemented. This takeover process would then end mirroring officially. It will mount the disks to the already installed HANA software and instances and start up the secondary database side of the cluster. If the host names and instance names on both sides of the clusters are identical, then no further steps are necessary. You could actually imagine that it would be possible to run a developmental QA instance of the 3-tier installation on this secondary cluster hardware to make full use of it. You can utilize it until the takeover is executed. When the takeover would then be done, these development or QA instances would mount the production disk to the host. It would require, obviously, another additional set of disks for development in QA. So far, no hot standby via log shipping is available, or when even log shipping by recovering of log backups on a standby host. Let's look a little bit about data coming into HANA. We're going to look at this more in detail in next unit, but there are different technologies how to load data into HANA. Some of these methods are landscape transformation, replication, data services, which is an SAP application, Sybase replication server, flat file upload, also direct extractor connection, which is DXC. It will continue on the concept of replication that leads us into looking at near HANA products, which is still part of the system landscape. So you could say that the full HANA system landscape, it actually contains products that are not really part of HANA itself. If we look at data service as an example, you will find it at the bottom left-hand side here. It could be used to then source data from ERP systems, from BW systems, or even non-SAP systems. You won't just have to use data service. You could also use the LT systems to replicate it, which is the next to the data sources there. Part of the near system landscape, you also have, for example, reporting products, as you see at the bottom right. Business service enterprise also are part of the system landscape. On the right-hand side, you will see end clients, end user workstations like Excel or web access to BI clients. But not to forget the HANA Studio, which we've looked at, that's also part of the system landscape. So would the Data Services Designer be your information design tool, part of Business Objects, or Excel even. So all of these tools, they make up the SAP HANA system landscape with the near HANA products. HANA is packaged differently depending on the different editions of HANA. So this would all depend on the needs of the customer that's finally targeted. We have the HANA platform, we have Enterprise, we have Enterprise Extended. The SLT toolset, it's actually part of the HANA license bundle free of charge. However, Business Objects is not. It's always installed on a separate service. So to go into packaging of these different editions, more into detail, you probably want to talk to sales or the licensing department. So the next method will deal with the persistence layer. One of the questions that's often raised about HANA is, what if the code to the server is unplugged? Do I lose all my data? No, that's why we have a persistence layer. The HANA database, it offers one persistence layer which is used by row store, column store, disk space store, and object store. The persistence layer is actually what it ensures that changes are durable and that the database can be restored to the most recent committed state after a restart. The persistent layer, it stores data in disk volumes that are organized in pages. You probably heard of page sizes. A lot of them are supported, 8K, 16, 64K, 112K, even 4 megabytes. Data is loaded from memory and stored to disk page. Data pages and what's called before images or undo log pages are written on the data volumes. After images, as in redo log pages, are written on the log volumes. So when is data log entries written to disk then? Well, the redo log entries are written to log volumes at latest when a transaction ends. Change data itself is written at latest when a save point is performed. So we have data in memory, SQL and undo log information, additional HANA information such as modeling data, and we have the log, which contains information about data changes, redo log, directly saved to persistent storage when transaction is committed, and during the save point, change data and the undo log is written from memory to persistent storage. Now this happens automatically. You can set it to an interval which is usable for you. For example, you would at least want it every 5 minutes. So let's look at what happens during the save point more in detail. These save point phases, they consist of 3 phases. During phase 1, all the modified pages are determined that are not yet written to disk. The save point coordinator then triggers writing of these pages. During phase 2, the write operations for the next phase, phase 3, are prepared. We will have to acquire a consistent change lock so that no write operations are allowed. All the pages are determined that were modified during phase 1 and written to a temporary buffer. We then get a list of open transactions, and the row store information for uncommitted changes made during phase 1 is written to disk. The current log position is determined, the log position from which logs must be read during a restart, and then the change log is released. During the log phase, phase 3, all the data is written to disk, and changes are allowed again during this phase. So the row store checkpoint is also invoked. The log queue is flushed up to the save point log position, and then a restart record is written, which contains the save point log position. Shadow paging is used to undo changes that were persisted since the last save point. With the shadow page concept, physical disk pages written by the last save point are not written until the next save point is successfully completed. Instead, new physical pages are used to persist changed logical pages. The shadow page, which still contains the version of the last save point, and the current physical page, which contains the changes written to disk after the last save point. So after a restart, the system is restored from the save point version of the data pages. This way, all data changes written since the last save point are automatically rolled back. After this save point is restored, the log is replayed to restore the most recent committed state. In the illustration here, you can see what happens between a save point and a power failure. The actions that actually happen during the system restart is that the last save point must be reloaded, plus any undo logs that must be read for uncommitted transaction saved with last save point. Also redo logs for committed transactions since the last save point. Then a complete content of the row store is loaded into memory. The column store tables may be marked for preload or not. Only tables that are marked for preload are loaded into memory during startup. So if tables are not marked, if they are instead loaded by demand, the restore procedure is invoked on the first access, so when an application or a query has selected from that table. So apart from the persistence layer, in the next lesson, we're also going to look at backup and recovery of HANA. So as you can see, it's a fully fledged database. You can restore backups into a separate database. Prerequisite for this would be that the physical layout is the same for both source and target database. So we'd have to have the same number of hosts. So if we want to do so, we'll have to first create a target database, have a proper installation in place. Then we'd have to copy the required backups to the target database backup folder. This would be done using operating system commands. So it's a normal file copy. After that, you can easily recover the target database to the desired point in time. So in order to create a backup, what is the procedure then? Well, the user would start the backup via the HANA Studio, which we've seen earlier. The database triggers a global database snapshot. And then commits for all transactions are put on hold. Master name and index service, they create snapshots of their persistent storage. So that commits are allowed again. And then the master name server and index service write snapshots to backup destinations. You can use the HANA Studio to monitor the progress, and we also recommend a manual configuration backup. So these are not big files, so they can easily be copied. So you have seen a similar timeline like the one we see on the screen now for power failure. Now this one shows it from a disk failure perspective. So in a disk failure, that's when data volumes are damaged. system can be restored to the state just before the failure, and we can even restore the log if the log area is undamaged and all log entries are still available. So for recovery, in general, there are 3 data sources involved in the recovery process. Data backups are stored in the file system, log backups are also stored in the file system, and then we have online logs. We'll look at the different recovery scenarios here. So to restore to state in data backup, which means using changes made after the data backup, we would, as a prerequisite, obviously need a data backup. And what we would do is to import the save point from the data backup file into the data area of the database, and restart the database from the restored save point and clear the log. We instead want to recover to the last committed state. We will need the data backup and the log since the backup. Again, we'd import the save point from the data backup files into the database. Restart the database from the save point and replay the log from the backup files that we then have available. On the other hand, if we want to do a point-in-time recovery, as in recover to any state that we've seen at a specific time, we would need the data backup from the time and also the log between the different states. So in order to do so, we'd again have to import the same point from the database, import the save point from the data backup files into the database, restore the database, and replay the log from the log backup. This would give us a point-in-time recovery. So you've now seen 3 different recovery scenarios that is possible. So if we just summarize it, what are the features in terms of backup and recovery? We can actually do a data backup. We can do a log backup. We can do a recovery to last data backup, recovery to status before crash, or even a point-in-time recovery. So the features in terms of backup and recovery shows that HANA is a fully fledged database in this sense. So in this chapter about the architecture, you've learned part of the architecture of HANA 1.0. You've learned about the persistence layer, and you've seen the concept of backup and recovery and the possibilities that we have at hand. So thank you for listening to this unit.